Hello, I'm Frank Kish, and I'm going to be presenting Introduction to the Navigation API for ArcGIS Runtime. For this presentation, I'll give you an overview of the API, talk about the components that make it up, describe a basic workflow, look at some of the objects in more detail, discuss some related topics, and then finally finish with some resources that you might find helpful. There will be demos interspersed through the presentation. First, for an overview. So exactly what is the Navigation API? Well, it's a collection of objects and events that are part of the core ArcGIS runtime. They're exposed in all the ArcGIS Runtime SDKs, so Android, iOS, etc. They're not a separate install, they're just part of the regular SDKs. And we first introduced this in 100.6. The API is used by the ArcGIS Navigator app, which is an Esri app. So if you want to see the API in action, you could download the Navigator app to get an idea of what's possible. Or alternatively, perhaps you can use the Navigator app itself instead of writing something from the ground up. It supports the concept of app links, so you can switch to and from an app and back again. One thing to note is the Navigation API is not part of the ArcGIS API for JavaScript. People have asked about this in the past, and the JavaScript API is completely separate from the runtime. So exactly what functionality does it provide? Well, it tracks your position along a given route. It returns information about progress along that route. It raises events at certain times while tracking. It transforms directions from a route into voice-friendly guidance. And it detects if you're off route and can automatically reroute. What are the requirements? Well, first you need an ArcGIS Runtime Basic license. And then the API works with a route result, so it's leveraging network analyst functionality from the runtime. You need some local data, so a mobile map package containing a transportation network, or you can use a routing service to do rerouting and routing. And then finally, you need to get a location from the device, and you need a text-to-speech engine of some sort. I point those couple things out because those are coming from the underlying platform. It's functionality that you would need for an application, but it's not necessarily part of our API. So we are relying on some of the device functionality. Okay, now for a quick demo. Here's an application that I'm going to show you. This one is built from the Qt SDK. So let me get out of the PowerPoint slides. I have to move over to, let's see. And there we go. All right. So as I said, this is a Qt application. I'm going to go through some of the functionality. Well, first we have this settings, and this is how you configure the app. So this allows you to input your GPS properties or points. So this can come from either a serial port. So if you've set your device up to that to use a serial port, or for simulation, which we're using here, the GPS points can come from a file. Next, you can load a mobile map package. I've already done that. We don't really need to look at that. Then routing. So we can use offline solves or local data, and that's coming from a transportation network in a mobile map package. And that's what we're using here. But you could also use an online solve where you place a URL in this text box to tell you where it should go to do the actual solve. And then finally, navigation settings. In this case, I'm showing the rerouting settings that you can set and get configured when you're setting up your route tracker. So let's add some stops. In this case, I'm actually adding them from a CSV, but you could add them manually. So next, I want to solve this route. So going from the first point to the second point, we get this route back, and up here we see that we're using these are the directions that come back. We can also look at the stops tab, and this is actually just showing the stops that were actually put in for these two locations. So the first thing I'm going to do here is click Navigate, and that's just creating a route tracker object for us. And then I'm going to push play, which will start walking through the GPS points. So as we see this is going, let's look at a little bit of the interface. First, these are the locations being pushed in, so the GPS points. And then when we look at the navigation tab, we can see information is changing as we get new points coming back from GPS. So we can look at our location is slightly changing, and our maneuver minutes and meters, destination, route, and our guidance. We can see guidance up here, and we can see over here, we can see that we're on route and we haven't reached our final destination. So I'm going to stop navigating. Now that just gives us context for what the rest of the presentation should be giving you. Now let's go back to extend mode so I can show you more slides. All right, so next let's look at the components of the API. So here's an overview of all the components that make up the navigation API. As you can see, it consists of a few classes and some events, but it's not huge or overwhelming. And now let's look at each of these a little bit more in detail. First, we have the route tracker. This is the main setup object. You pass a route result object into its constructor when you create it. And there's method on here to set the parameters for rerouting, which we talked about when I was showing you the demo. The route tracker object is also where the GPS points are passed into, and it's also what raises the events, which we'll look at in a few moments. Next, we have the tracking status class. This contains the information about progress along a route when a GPS location is passed in. You might display this information in the UI, or you might have some sort of application logic that kicks in based upon the value of one of these properties. I'll show you something like that later on. Next, we have events. We have a tracking status change event. This one's raised when new locations are passed in, and it returns a tracking status object. We have a new voice guidance. That's giving us voice guidance, which is just a text or string that you would pass to the text-to-speech engine. And it's raised at key positions along a route. And then finally, you have rerouting started and rerouting completed. As they sound, they're raised when a rerouting event starts and when it's completed. So you might need to get user some feedback or do some sort of other application logic during that time. And finally, we have the voice guidance and some enums. The voice guidance is text, as I said, that you can pass to a speech engine. Now, it's derived from the route directions, but has some added information, like distance based on your current location. And the enums are returned as properties from some of the objects. So let's look at a basic workflow. As an overview, you have four main areas to deal with. You need to generate a route result via a route task. You need to create a route tracker object and pass in the route result. You need to pass in GPS locations to the route tracker. And then you need to respond to events that the route tracker object is raising. So let's break down these a bit more. To generate a route result, well, first you need to create a route task from a transportation network or a service. You need to specify stops and set your routing parameters, and then you do a solve, which brings back a route result. So let's look at how this looks like in code. So first, we create a route task. We're passing in a transportation network, and we get a route task back. Next, we create the default parameters from a route task. That's using the underlying transportation network or service to create the beginning properties of the parameters. Next, we can set some properties. So here we are setting stops. So we're passing in this case, the stops is a list. You don't see that in the code, but that's what we're doing. And then I set a couple other properties like return stops and return directions. To navigate, we need those stops to come back and the directions to come back in the route result. And then finally, we do a solve, handing the parameters to the route task and the solve route async method, and we get the route result. Next, we want to create a route tracker object. We do this by passing in the previously created route result into the constructor. Then we wire up the events, and we enable rerouting if supported or required. And let's look at the code. First, we create a route tracker object passing in the route result. Next, you wire up a couple events. So in this case, I'm wiring up the status changed event and the new voice guidance. And then I check to see if we support rerouting. This really relates only to services, and we'll talk about that in a little while. Next, I enable the rerouting. So I'm passing in the route task and the parameters and our rerouting strategy. And we'll talk about that in a little while also. And now I'm actually wiring up the event. So in this case, I'm wiring up the reroute started and reroute completed. Okay, and finally, we want to pass in the current location and respond to the events. You might want to be updating the UI based upon which events are raised and what they bring back. So if we look at some code, we pass into the route tracker and into a method. We pass the location from the device that you're currently at. And if we're responding to something like a new voice guidance event, we might take that voice guidance and show it to the user in some sort of text form, but we also might pass it to some sort of text-to-speech engine. Okay, let's go to our next demo. All right, we'll change presentation mode. And there. So this is actually an application written in the .NET SDK. So I'm going to actually just play it from Visual Studio. Okay, it's kind of similar to the last application. In this case, I've loaded California map. And right now I'm going to zoom to the Palm Springs area. Now I've hard-coded in some stops. So our stops are coming back, or I've added the stops to the map. And I'm actually going to now solve. And we just get a pretty simple route back, straight line. We get our directions back that I'm showing over here, some information about the route, so its total length and the time it would take to traverse it. I've also put the directions in different form over here. So what I'm going to show now is what happens when you go off route. I have GPS points I'm going to simulate. You can see them in blue that I've just drawn. And as you see here, we're going to go off route. So first thing I want to do is create a route tracker object and start the GPS. So we see it going along, and it's going to turn, and we see that we get a new route back after we went off route. Now let me stop the GPS for a second. In this particular case, it's decided to move back along the route, doing a U-turn. That's how it decided the best method to get back to these other locations are. So now let's do that whole demo again, but in this case, we're going to actually do it with a service. So let's add the stops again, and we're going to solve, and then GPS locations back on, create route, And let me open Fiddler up so I can show you that we're making a call. We're going to start the GPS locations. We should see in a second when it goes off route. There we go. I've made a call to a server I have, and it does a web call to the solve. So in this case, we're doing something very similar, getting something very similar back. This is how the GPS or the going off route works, both with local data, so mobile map package transportation network, or with going with services. Let's close that down. We'll go back to our presentation. All right. Now, let's look at the objects in a bit more detail. And first, we're going to look at the route tracker class. So first, we're going to look at the method for enabling rerouting. As you can see from the method signature highlighted here in red, pass in a route task, route parameters, and rerouting strategy. So when rerouting is enabled and you go off route, the API will do a new solve in the background, and it resets the route tracker object. So its state is updated to reflect the new route that you have. The solve uses the passed in route task and route parameter objects, and we'll talk a bit more of those later on. And the rerouting strategy that you pass in determines how the remaining locations are used in a resolve. So you have three options. First, to the next stop. This reroutes you directly to the next stop, and if you have waypoints, it drops all those up to the next stop. So it goes directly to the next stop using the best path possible. Any waypoints beyond the next stop, though, will still be continued to use. Again, the next one is to next waypoint. So if you have waypoints and it does resolve, it's going to take you back to the closest waypoint that hasn't been visited yet. If there are no waypoints, though, it just reroutes you to the next stop. You would use this strategy if for some cases where you need to follow a very specific path. And then we have resequence stops only. This optimizes the resolve. So it allows them to resequence the stops. It will drop any waypoints because when you're doing optimized routing, we don't allow waypoints. And I want to note, rerouting is optional. You don't actually have to have it set up. And you can also disable it. By that, I mean, if you've enabled it, you can also turn it off. Since we're talking about rerouting, I'd like to point out that the route tracker uses all the location properties to determine if it's en route. It mainly uses the X, Y, and bearing to determine if off route, but the velocity and time are also taken into account for various properties of the reroute. So if you're simulating, all these values should be accurate and consistent. When you're getting GPS locations, they are what they are. But if you're doing some sort of simulation, you want to make sure all of those values are consistent. Also related to this is question of exactly what is off-route. So we considered 32 meters to be off-route, which is about 2% of a mile, if you're moving away from the segment with a different bearing. Now let's look at a few more things on the route tracker object. We have a tracking status object, we have generate voice guidance, we have switch next destination. So with the tracking status object property, you get back a tracking status object directly from the route tracker. This can allow you to access the information on a tracking status object outside the event that passes back a similar object. It can be helpful if you want to get the information from this from a tracking status object manually. The generate voice guidance method generates voice guidance directly from the route tracker. This can allow you to get that if you need it at a certain point along the route without waiting for the voice guidance event to fire. So for example, you might want to have some sort of user interaction where they interact with the app to allow you to either repeat the voice guidance or such. And then switch to next destination method. This is what updates the internal state of the route tracker object to move on to the next set of direction maneuvers. You call this method after you're done at a stop and want to move to the next one. And now let's look at some of the events. These are the various events that I mentioned previously that you might want to wire up. Now, the tracking status change event fires each time a new location object is passed in, and you get back a tracking status object. Obviously, the rerouting started and rerouting completed fire when you're off route and rerouting is started and completed. So, the voice guidance event is automatically raised at key positions along a maneuver. In general, it's raised about 3 times. First, at the start of the maneuver, the voice guidance at this point would be like the full text of the guidance, something like, in half a mile, turn right on North Eureka Street. The second time it's raised is when you're approaching a maneuver. So it might be when you're about 20 to 30 seconds out before the next maneuver. This is a slightly condensed version of the guidance, so it might just be turn right on North Eureka Street. And then finally, when you are close, about 9 or 10 seconds away from the next maneuver, it might give you a brief version of the guidance, something like turn right. As I said, this is just a general guideline. The speed of the vehicle, the length of the text of the voice guidance, the time it takes to voice that, the time to the next maneuver, all have an effect on the exact timing of the guidance and when the event is fired and what is returned. So now let's take a look at the tracking status object. We have a few properties we're going to look at that I'm highlighting here, like current maneuver index, display location, remaining destination count, and route result. The current maneuver index allows you to know where in the array of directions that the current voice guidance came from. So, as I said previously, voice guidance comes from your directions, and if you need to map yourself back from the present voice guidance to the actual directions objects, you can do that with this method. The display location provides a location that's snapped to the route. You can display this location on the map. It compensates for the fact that GPS locations might not be 100% accurate and may be wandering on and off the route path slightly. So if you use this to display your location, it shows you traveling directly along the route. The remaining destination count allows you to know how many more stops need to be visited, and you can use this to display the user or checking where you are within the array of stops. Have a graphic here on the slide that shows this is from the first app that I showed. And then finally, the route result is a property that initially contains the original route result used when you created the route tracker, but during a rerouting event, this property is updated to allow you to get to the new updated route result that was created by an internal solve in the route tracker. Let's look at a few more on this object. We have destination progress, is on route, and route result. Is on route, that just checks if it's a Boolean, and it checks if you are on route and tells you whether or not you're actually on route or not. It's slightly different from the event because the event fires only if rerouting is enabled. Next, the destination status allows you to know if you're nearing or add a destination. I'll discuss this in a bit more detail when we get to the enums. And finally, destination progress. In this gives you information regarding the distance, time, and geometry that takes you to the next stop for your present location. So you can see from the graphic on this slide here, we're showing that, and this is from the first demo, and it gives us the minutes and meters to the next destination. And that was, if you recall, updating as each new GPS point came in. Similar to the destination progress, you can get distance, time, and geometry either for the present maneuver, so that's different from the destination progress because that's to the stop. This is for a specific maneuver, which there are multiple for a particular path to an object or to a destination. And we also have the same thing for the whole route. Finally, voice guidance and the enums. The voice guidance, well, this is a string that gets passed, that you can pass to a text-to-speech engine. The text of it contains rounded distance. By what I mean, if you're like half a mile away or about half a mile away, we kind of round up and down depending upon where you are within a particular range. And we have specific ranges. So it's more similar to how someone might tell you guidance as you were driving. So we're not giving the exact values, but you could get the exact values from the tracking status object itself. As I said previously, the voice guidance is generated from directions text from a specific route. But there are times when two directions might be combined. This is mainly when there are two or more very short maneuvers, and they might get combined into something like turn right and then turn left. So if you have a quick two maneuvers in a row, we're not going to say those individually. You can also get the type of maneuver, and you can use this to maybe display a graphic on the UI to show them what that maneuver, the next maneuver coming up is. Then we also have the destination status enum. As mentioned previously, the tracking status returns a destination status. This can be used to determine relatively how close you are to a destination without looking at the actual distance value. It starts out at not reach, which is where you first begin. Then if you're within 500 meters of your destination, it changes to approaching. And then finally at 40 meters, it may switch to reached. This is dependent upon if you're moving closer to the stop or not. If you continue to move closer, when it gets to 7 meters, it will switch to reached. If you start moving away and you're still within that 40-meter range, it will then switch to reached. So let's talk about some related topics. These are things that are not necessarily in the navigation API itself, but most likely you'll use or need to know about when creating an application. First, you need to be familiar with the display location and location data source. The map view has a display location property, and this is what allows you to display your current position on the map. Each platform should provide a method to get to provides a method to get to the device's current location, and the ArcGIS Runtime SDKs access that. Usually this requires an app to request permissions to do this, so you should note that. And each platform, and hence each SDK, has a slightly different name. For example, there's an Android location data source if you're on Android, so you'd need to consult the SDK help to figure it out for which one you happen to be using. Also to note, the device determines the source of the location. That is, it might be GPS, but it also might be using Wi-Fi or cellular or some default location to determine where you are. The runtime also provides the ability to implement a custom data source. This is where you create your own location data source. You could use this if you're doing simulation for testing and demoing. Demos in this presentation is they use the custom data source to simulate GPS. But we are working on something to make this a little bit simpler, so we're working on providing a simulation data source directly in the SDK. Also, using a custom data source is how you can display the tracking status display location as your current position. Again, this is what the demo in this presentation used, and you can consult the code when we share it for more details about that. You also might want to look at the help under the guide section about showing your device's location. Routing services. So we can allow rerouting with routing services, but this was first added at 100.7. Previously at 100.6, when we first released this, was blocked. But there are two requirements to use a service for automatic rerouting. First, you need the property license for automatic rerouting to be set to true, shown in the screenshot. And second, and this is related to that, is that you need to be using ArcGIS Server 10.8 or higher. And this is required because this is where that property was first introduced. And that being said, if you're using services, you always need to take into account, where they are. Are they public? Are they behind a firewall? What security do you have for them? You need to consider how many people are using them, network connectivity, latency, anything that you would have to deal with if you're doing a service. So you have to think about that versus using mobile map packages and transportation networks. And one thing to note is presently the ArcGIS.com routing service does not allow you to use this for automatic rerouting. That property is set to false. And the network analyst is a key part to creating a good navigation app. It determines what the route is and the properties. To highlight some of the components, first off, we have a route task, which we talked about briefly previously. A route task is what we can be created with using a transportation network or a route service. The network data set that contains that is in the underlying network or service. This is where your potential costs and restrictions are defined. A cost might be something like travel time, and a restriction might be something like avoid toll roads. Directly related to these costs and restrictions are travel modes, and this is a grouping of costs and restrictions into logical units, as opposed to having to set each individual one up at a time. This is a way to group them. So you might have like a truck time, travel time mode, or you may have a car traveling time or a car distance travel mode. They use the grouping of costs and restrictions to do the solve. You also do configure how your directions come back in the network data set. And the directions are what determine the voice guidance. The routing parameter objects allows you to set properties for the solve. So this is where you set the travel mode, but you can also set something like start time. We also support the idea of barriers, so you can prevent a route from traveling in certain areas, such as polygon barriers. And those come from digitized locally or from a service. A little bit more on Network Analyst. We can also support the idea of using waypoints. These are really just specialized stops, and they influence the path but they're not included in the directions, so there's no voice guidance provided for these locations. Waypoints are included when solving a route so that you can affect the overall path, but they also, because they are just regular stops really, it will have an effect on the performance of them. So you don't want to overload your route with tons of waypoints. Regarding local data, mobile map packages or MMBKs are created using ArcGIS Pro with a GP tool. MMBKs support a variety of layer types, and so you want to consult the Pro help for more information about the ins and outs of creating one of them. One thing to note is that the base map, when creating a mobile map package, is compressed. So if you put your data in there that's just base map type data you don't need to interact with but just show in the background, that will give you some space savings. The network data set should also be probably put into the base map. This is how we create mobile map packages for SMP data, Street Map Premium data, that is. And since I mentioned that, Street Map Premium for ArcGIS Runtime. If you don't have your own data or network data set, we also have a product that has that you can purchase for ArcGIS Runtime usage, and that has base map data, network, and locators. We also support the concept of route layers. Route layer is a planned route that can be created with various tools in Pro or ArcGIS Online. It would be saved to a portal as an item, and then you can download it to the device. From it, you can create a route result or extract a route result and the route parameters that were used to create it. There's some caveats about that, as in the route result the route parameters need to exist in whatever data set you're using. And if you go off route, it will do a resolve. So you need some sort of local data or a service. To help ensure that you follow an original path, though, if you need to do that, you're going to want to include some waypoints to help direct the path. And now for one more demo. Let's move back to duplicate. And we're going to go back to this previous application. And in this case, we're going to zoom into the Palm Springs area again. We're going to add some stops. Then we're going to solve. But before we do a solve, we're not going to allow U-turns. This is a property of the travel mode, and I'm programmatically resetting that so that it won't be allowed to do a U-turn. If you recall, the last time we did this, it did a U-turn around here and came back and went to the other stops. So let's do a solve. Obviously, it doesn't do anything to the initial solve, but if we have our GPS points that we're going to go off route, let's create the route tracker and start following that. Now we're going to wait for it to go off route, and we'll see that it follows a different path this time. It doesn't do the U-turn. I'm going to stop this, clear everything. Now let's do that again, but this time we're going to add a barrier. Move to the beginning again, add our GPS points. Now this barrier should prevent something from happening when we do the off. Oops, sorry. This barrier should prevent the solve from happening the way it did the last time we just did it. Let's create route tracker and start GPS. As we watch it, and it's about to go off route. Again, we see that it's actually created a new route, but it hasn't done the U-turns and it's avoided the barrier. So let's stop this. Now, let's clear everything. One more demo. I'm going to add different stops and turn that on, and I'm going to solve. Now, what we see here is it takes 2 minutes and 20 seconds or so to do this solve, or to do this route. This time I'm going to say I want to send some notifications. I'm going to get the GPS points, but I'm going to generate them from the route because I want to follow that route. Then we're going to create a route tracker, and we're going to start the GPS. Go back to the beginning, and we can watch as it counts down to less than 2 minutes. What I'm doing in the background is I'm tracking that particular value, and once it gets to 2 minutes, it should send an email off to maybe it didn't. All right. I might not be set up to have an email sent properly, I think. All right, well, either way, one thing you can do if we look at the code in here, if we go to some of, you could be checking for destination progress remaining time and see if it's under some sort of value. And then what's supposed to happen is I'm supposed to send an email using my notifications. And I should get an email. I'm probably just not set up on the internal network because I'm using my Esri email address at this point. So let's go back to the presentation and finish off. So in summary, you want to use the route tracker to set up. That's your main setup object. You want to track status to get progress, and you want to respond to events. That's basically how you use the API. You want to familiarize yourself with network analyst concepts, and then you need local data, mobile map package, and with the transportation network, or you want to use services. For displaying position, you're going to want to use the location display and a location data source. Some references that I'm going to leave you with are some here, and once you get these slides and they're provided for you, you can follow these links for some more information. That's the end. Thank you.